Okay, I'll come back to that reaction in a moment, but let's start off with chloride first. So just to emphasize that these reactions will only happen if I'm using solid halides and concentrated sulfuric acid. And when we react the chloride with sulfuric acid, we don't get any kind of reduction, we just get the HCl. The other product is NaHSO4, sodium hydrogen sulfate. So the HCl appears as little puffs of white fumes, white misty fumes, it's sometimes described as. And the NaHSO4 would just be would dissolve in solution, so you don't really see it. Okay, it's not a redox reaction. What kind of a reaction is it? If we would describe it as a type of reaction, what would we?
Displacement.
So displacement reactions are usually redox reactions. So we talk about zinc and copper sulfate, or chlorine and sodium bromide. They usually involve some redox. So that's not quite right. But I know what you mean, because the NaCl, it's like it's swapped for an H, so we've made HCl. It does look like they've kind of changed places. The focus is really on that H.
Is it neutralization?
Yeah, yes and no. So we've got an acid reacting with something, and the acid has reacted by putting its proton, the H plus, onto the chlorine. And that's our definition of an acid. An acid donates H plus ions. So that's behaved like an acid, and the chloride has behaved like a base. But it's not neutralized it because we've made another acid. But if we were going to classify it as anything, it would have to be as an acid-base reaction. Even though it's a bit of an odd one, because it also makes another acid. Anyway, let's move on. If I start off with sodium bromide, then we get the same reaction first. We get HBr made and NaHSO4. So an identical reaction to sodium chloride. It's just that then the HBr reacts more. So and this is the reaction that we had on the board before. Somebody had it balanced for us.
H2SO4 plus 2 HBr, Br2 plus SO2 plus 2 H2O.
Okay. So what's the oxidation state of sulfur in H2SO4, Tom?
6.
Thank you. And in SO2?
4.
Okay. So we could imagine this on a kind of scale. So we've started with H2SO4. Sulfur's right at the top there. +6 is as high as it goes. And it's come down to, +4. But we know that sulfur can occupy lower oxidation states. Of course, there's sulfur itself, the element, would have an oxidation state of 0, and then H2S would be even lower, down at -2. So sulfur's got this whole range. The chloride can't reduce the sulfur at all. It's still at +6 here. The bromide is a stronger reducing agent. It can reduce the sulfur, sorry, that one down to +4, but that's, again, as far as it can get. Just before we go on, let's say you're asked to write an equation, so imagine this, write an equation for the reaction of sodium bromide and H2SO4 to make bromine and SO2. Just before we talk about iodide, let's just solve that particular problem. Write an equation for the reaction of sodium bromide and H2SO4 to make bromine and SO2. And just have a go, have a little fiddle, and see if anything pops up. And I'll pause the video for a moment. Yeah, so the trick here, like balancing electrons with two half equations, we look at what's common. What have I got in the products of the first reaction that's in the reactants of the second reaction? Well, it's the HBr. So I'm going to have to make sure that I've got the same number of HBr's in both equations. So if I double everything in the first reaction, so I've got 2 HBr's and 2 HBr's, now I can do what we do with half equations. I can add everything on the left to everything on the left. So I'll get the 2 NABR's, and of course I've now got 3 H2SO4's, and then the HBr's will cancel. I'll just move that over. We'll make the 2 HBr's, well they've cancelled by design. 2 NaHSO4, and then everything else on the right, Br2, SO2, 2H2O. Okay, so that gives us a single equation that combines the sodium bromide and the H2SO4 on the left and gives us the bromine and the SO2 on the right. And hopefully it all still balances. Always a worry. Right, iodide. So, sodium iodide reacts with the H2SO4 in the same way as the first reaction for NaCl and NABr. So can you write the equation for that reaction first? Thanks. So we'll be making Hi as our product. And then we're going to write a second reaction for Hi and H2SO4 to make SO2. So can you complete that reaction as well? Okay, so we should have Hi and NaHSO4 on the top, and then 2 Hi and H2SO4 makes SO2, I2 and 2H2O, exactly the same as the last reaction. Okay, but iodide can go further, whereas chloride didn't react at all. Bromide only took us down as far as SO2. Iodide is going to take us all the way down to H2S. So Let's do sulfur first. And iodine will be the other product. Could you give me a balanced version of that equation, please? You can, of course, go and balance the two half equations separately, and lots of you might need to do that, and that's fine. Or you could just have a quick look at the oxidation states of sulfur here. Sulfur in sulfate is +6, and sulfur the element is 0. So that's 6 electrons. Each Hi gives away how many electrons? Just the one. Yeah, iodide goes to iodine and gives away 1 electron. If it was 2 iodides, it would be 2 electrons. I need 6 electrons, so it must be a 6 in front there. And then everything else will just kind of fall into place after that. You should be able to balance it all from there, putting in the appropriate waters that you need. Can I leave you to finish that one and have a go at a similar one, which is Hi reacting with H2SO4, but this time to make H2S. Could you balance that equation as well? Thank you. And see if you can use the shortcut to do it. Can we just finish with? Well, let's do this first of all. That should be 4H2O on the right there, shouldn't it? And then because we've got 6Hi, we'll need 3I2. What do I need to balance this?
It's 8Hi.
8. Yeah, because we're going from +6 down to -2 this time. That's an 8 electron change. So we need 8 iodides to give us the 8 electrons that sulfur needs to get all the way down to H2S. And then, keep going.
And then you need 4I2 plus 4H2O.
Okay, so as I was just saying to Patrick there a minute ago, it's more complicated than this because we need a reaction to go from SO2 to sulfur and SO2 to H2S and sulfur to H2S. So there's a whole bunch of different reactions. We're not expected to remember them all, but you should be able to balance them kind of on the fly in an exam. We'll come back to that later. Cheers, gents.